Breaking news, 3I/Atlas isn't acting like any comet we've seen. Its tail, carbon dioxide outbursts, and even nickel traces.
Fresh spectroscopic data from 3I/Atlas, the third confirmed interstellar visitor to our solar system, has revealed something that shouldn't exist in nature. Racing toward us at over 152,000 miles per hour, this mysterious wanderer carries a secret that's sending shockwaves through the scientific community. With only 66 days remaining until October 29, 2025, when 3I/Atlas reaches perihelion and vanishes behind our sun's glare, researchers have made a discovery that challenges everything we know about cosmic formation. The revelation is staggering. 3I/Atlas appears to be composed of pure nickel. Not the nickel-iron alloy found throughout our solar system. Not the mixed metallic compounds that make up asteroids and meteorites, but elemental nickel in its refined state. This is a composition that nature simply doesn't produce on its own. Time is running short for humanity's greatest cosmic detective story. An enigmatic object from the depths of interstellar space continues its relentless approach toward our sun, and when it reaches that crucial moment of closest approach, something extraordinary will occur. Earth, our star, and 3I/Atlas will form a perfect line, creating a celestial blind spot just when we need visibility the most. This isn't merely unfortunate timing. It's a cosmic conspiracy. Global observatories have been tracking this peculiar visitor, attempting to decode its unusual characteristics. Unlike typical comets, it shows no streaming tail, releases no water vapor, and maintains a solid, reflective surface that bounces light in ways that suggest industrial precision rather than natural formation. The object resembles a manufactured projectile more than a cosmic drifter. Once perihelion passes, 3I/Atlas will begin its permanent exodus from our solar system. Miss this opportunity and humanity will never get another chance to study this anomaly. NASA's premier instruments, including Hubble and James Webb, are already locked onto the target. However, even these technological marvels will be powerless against the sun's overwhelming brilliance during the alignment. For those critical hours, the most enigmatic object ever cataloged will simply vanish from view. For months, whispers circulated through research circles about this visitor's unusual properties, but recent spectroscopic analysis has uncovered something that defies cosmic chemistry. 3I/Atlas isn't just another space rock. Its surface composition reads as nearly pure nickel, a metallic signature that occurs nowhere else in the known universe without artificial refinement. This discovery represents more than scientific curiosity. It's a fundamental challenge to our understanding of how celestial bodies form. In every corner of our solar system, from the smallest meteorite to the largest asteroid, nickel and iron exist as inseparable partners. This cosmic marriage is so universal that finding one without the other is like discovering water that flows upward. Nickel-iron alloys form naturally through stellar nucleosynthesis and planetary accretion processes. But pure nickel? That requires industrial separation, controlled environments, and deliberate refinement, processes that don't exist in the vacuum of space. Consider the implications. Even on Earth, extracting pure nickel from its natural iron-bound state requires sophisticated smelting, chemical processing, and industrial infrastructure. The fact that 3I/Atlas displays this refined metallic signature suggests origins far more complex than simple cosmic debris. At nearly 12 miles across, this visitor carries enough pure nickel to supply Earth's industrial needs for millennia. The sheer quantity of processed metal racing through our solar system represents a concentration of processed material that natural forces simply cannot produce. Interstellar space operates like an enormous cold desert, sparse, dark, and nearly devoid of the raw materials needed for large-scale construction. The density of solid matter between stars registers at levels 10,000 times too low to naturally accumulate objects of this scale, let alone refine metals to industrial purity. According to established astrophysics, the formation of pure nickel deposits requires specific temperature ranges, controlled chemical environments, and separation processes that exist only within advanced technological frameworks. The metallurgy alone suggests engineering capabilities beyond natural cosmic processes. This metallic composition also explains the object's unusual optical properties. Pure nickel possesses distinctive reflective characteristics, bouncing sunlight with an intensity and clarity that fragmented or alloyed materials cannot match. From over 300 million miles away, 3I/Atlas shines with the sharp, consistent brilliance of polished metal rather than the irregular scattering typical of natural rock formations. The spectroscopic signature is unmistakable. Wavelengths absorbed and reflected in patterns consistent with refined nickel, not the messy amalgamations found in naturally formed celestial bodies. This level of metallurgical purity points towards intentional processing rather than accidental cosmic chemistry. Traditional comets approaching our Sun undergo predictable transformations. Solar heat sublimes frozen gases, creating spectacular tails and glowing comas that stretch across millions of miles. 3I Atlas refuses to follow this script. Despite its proximity to solar radiation zones where water ice should be vaporizing vigorously, this visitor shows no signs of typical comet activity. No sprawling dust trails, no magnificent tail structures, no evidence that the Sun's energy is breaking down its surface composition. Instead, infrared analysis reveals only modest carbon dioxide outgassing, approximately 150 pounds per second, forming a thin atmospheric envelope spanning roughly 215,000 miles. This gas release appears controlled, almost regulated, like a protective system managing surface exposure rather than chaotic ice sublimation. The absence of water vapor is particularly telling. Most comets this close to our Sun would be venting water like pressurized vessels. 3I Atlas remains bone dry, suggesting either an absence of water ice or an exterior shell impervious to solar heating. Spectral data indicates surface materials including frozen carbon dioxide, traces of water ice, and dark organic compounds, compositions expected from distant Kuiper Belt objects. Yet even these outer solar system wanderers display vigorous activity when approaching the Sun. This visitor maintains its composure, suggesting a protective exterior designed to withstand solar bombardment. One spacecraft remains positioned to potentially encounter this mysterious visitor, Juno, currently orbiting Jupiter since 2016. Originally designed for atmospheric and magnetic field studies of the gas giant, Juno now represents humanity's only realistic chance for close-range observation of 3I Atlas. The geometry works in our favor. As 3I Atlas follows its hyperbolic escape trajectory, it will pass relatively near Jupiter's orbital zone during its solar system exit. This positioning places Juno uniquely among all active spacecraft. It's the sole probe anywhere near the object's projected flight path. However, significant challenges complicate this potential intercept mission. Juno's primary engine shows signs of degradation, and fuel reserves are critically low. NASA had previously committed the spacecraft to extended Jovian observation, deliberately avoiding major trajectory adjustments to preserve remaining operational life. Intercepting an object traveling at over 150,000 miles per hour would demand flawless navigation calculations, perfect timing, and a fully functional propulsion system, requirements that push Juno beyond its current capabilities. Still, mission planners haven't dismissed the possibility entirely. Even a distant flyby, close enough to collect magnetic field measurements, plasma data, or high-resolution imagery, would mark the first direct spacecraft encounter with any interstellar object in human history. Neither Oumuamua nor 2I Borisov received close-up visits from our robotic explorers. Harvard astrophysicist Avi Loeb, known for challenging conventional cosmic interpretations, has proposed what many consider a radical explanation. What if 3I Atlas represents technology rather than natural formation? What if its pure nickel composition points toward artificial construction rather than cosmic accident? The evidence supporting this hypothesis extends beyond mere metallic composition. This object maintains structural integrity while racing through space at tremendous velocity. Its surface remains stable despite exposure to cosmic radiation, solar heating, and gravitational stresses that would fragment typical asteroid or comet materials. The controlled carbon dioxide outgassing suggests systematic surface ablation, perhaps a protective coating gradually wearing away to reveal the refined metallic core beneath. Mathematical models indicate this gas loss removes approximately 1 millimeter of surface material per decade, an incredibly slow erosion rate that hints at engineered durability. If 3I Atlas represents an artificial probe from another stellar system, its builders would logically choose materials capable of surviving interstellar transit. Pure metals like nickel offer exceptional corrosion resistance, maintain structural stability across extreme temperature ranges, and provide the reflective properties necessary for long-distance visibility.
Consider the engineering logic. Any civilization capable of interstellar travel would construct their probes using the most durable, refined materials available. Pure metals like nickel offer advantages over natural alloys, greater predictability, enhanced longevity, and superior performance under extreme conditions. This isn't the first time Loeb has suggested artificial origins for interstellar visitors. His analysis of Oumuamua raised similar questions about objects that refuse to behave according to natural cosmic models. With 3I Atlas displaying even more anomalous characteristics, including its impossible metallic purity, the technological hypothesis gains credibility. Scientific skeptics dismiss these extraordinary claims, insisting that 3I Atlas represents merely another unusual comet variant. However, no conventional explanation adequately addresses the pure nickel composition, the absence of typical comet behavior, or the object's remarkable structural integrity. The clock continues its relentless countdown toward perihelion. In mere weeks, 3I Atlas will sweep around our Sun and begin its final departure from our solar system. This narrow window represents humanity's sole opportunity to gather definitive data about the most mysterious visitor ever detected. Whether 3I Atlas proves to be an exotic natural phenomenon or evidence of extraterrestrial engineering, its pure nickel signature has already rewritten textbooks about cosmic chemistry. The discovery that refined metals can traverse interstellar space challenges fundamental assumptions about how matter behaves in the universe's coldest, emptiest regions.